I'm going to model solving double-digit addition problems using base 10 blocks. This is a strategy that we're working on in class, and it's a very concrete way of looking at an addition problem. This is kind of one of the first steps before we get to just solving addition problems with only numbers and no manipulatives or drawings or pictures. So to start out, I'll explain what base 10 blocks are. They are blocks that are designed to help students understand the base 10 number system. And the most basic base 10 block is called a unit. And when we're using the real blocks in class, it just looks like a little cube. And it represents the value of 1. So this little unit equals 1. Whenever we're drawing a base 10 block, instead of drawing it as an actual square, we just draw it as a little circle, or a little dot. Let's see if I can get a dot to draw. We draw it as a dot because it's a lot quicker than drawing squares. So this unit represents 1, and then the next base 10 block is called a 10 long, and in class it's just 10 little units that are stuck together to make a rod, and there will be 10 units in one rod. I don't think that's exactly 10, but you get the idea. That equals 10. But when we're drawing it in class, we just draw a straight line because that's a lot faster than drawing all the little blocks of 10. So this represents 1. If you see this, it represents 10. And you can also represent 100 using a 100 flat. And a 100 flat is 10 of these little rods put together to make up 100. So 10 tens equals 100, and it looks like this, and it's got 10 of those rods. I don't think that's actually 10 again, and then 10 that go this way, and I don't think that's 100, but you get the idea. That equals 100. But when we're drawing a 100 flat, we just draw it like this. So our drawings are very simple and very easy so that we don't spend a lot of time focused on the actual lines, but we spend time on what the actual value is. For our double-digit addition today, we won't be using the 100 flat, but I wanted you to see what that is in case your kids want to talk about it or show it to you. So to use base 10 blocks to solve a double-digit addition problem, if I want to solve the problem 23 plus 56, I can use base 10 blocks to do that so that I can see what it looks like when I put 23 and 56 together. So I'll start with the top addend. I'm going to start by representing 23, and I would do that by drawing 1 10 long, 2 10 longs. So this is a value of 10, then a value of 20, and then I'll draw 3 units. So I have 21, 22, 23. Now I'll represent the bottom addend of 56. I have 10, 20, 30, 40, 50, 51, 52, 53, 54, 55, 56. So now I've represented the top addend of 23 and the bottom addend of 56. So the next step is to put the ones together. Even though we're not using any regrouping here, we want students to get used to starting in the ones column and seeing if that group of ones can create a group of tens. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I don't have enough for a group of 10. So I'll leave all the ones together. And I know that in my answer now, in the ones place, I'm going to have 9. Now I'll find out what's in the tens place. I'm going to count my tens. 1, 2, 3, 4, 5, 6, 7 tens, which has a value of 70. So 7 tens. Now I know that 23 plus 56 has a value of 79. That's how you can use base 10 blocks to solve double-digit addition problems without regrouping.